So I said energy is the ability to do work. So I went on to say that the end product of energy is that you need to do work. So if you have energy and you're not using it to do work, you have energy and it's wasting. So, and when you have that kind of energy and you're not doing work, it's called potential energy. And we've seen when we did this potential, we did work that has to do with going up or coming down. When force and displacement is going in the same direction, we have it to be mgh. So work and energy is equals to work. So if I know that, there's a question before us that says derive kinetic energy formula. So we can say that work is equals to F times S. That is when there is no angle. And we know that force is equals to MA. Force is equals to MA. And notice that A is equals to V over T. So you can see that inside work, we have momentum. Because notice that I'm trying to replace force with everything I have here. So notice that mass times velocity is the same thing as momentum. So S now. Remember that S means displacement. And if you remember, there's an equation of kinematics that says that UT plus half AT square is equals to displacement. So if that be the case, the A here is the same thing as V over T. So let's say I bring it out. So I now do S equals to, at initial velocity, this will be 0. 0 times T is 0. So let's say starting from rest. Then when we are dealing with final velocity, all of them can still correspond because at final velocity there will be nothing. So here, consider this to be at initial. So half A, now replace it with V over T, then times T square. Notice that this will take care of this. So that you have S to be equals to half VT. So if I carry this and replace for S, it will give me half VT. So this is for S. So you can very well see that this is the same thing as saying work is equals to, bring the half one side. Bring it first. Half M V times V square, then T all over T. This will take care of this. So you have that work is equals to half mv square. Another way to derive this is, I know that there's a formula which is v square equals to u square plus 2as. Notice that at initial velocity this will be 0. So v is equals to 2as. Right? So let's divide both sides by 2. Divide both sides by 2. This will cancel this. You see that this is the same thing as saying as equals to half v. Shebi? Half v. And as is the same thing as saying, if you look at work is equals to fs, shebi? And f is the same thing as saying ma. So we can replace everything here, then have s here. So notice that if I put this to be in such a way that I have mas, is the same thing with this. So now replace as with half v. Are you seeing it? Okay, but before I do that, let's remember that inside this let's remember that inside the A, I have V over T. Right? Let's be sure. Okay, so notice something. This is over 2. Remember that our V is carrying square. square. Yes, remember. So we almost missed that. So replace, I think it's best this way. So we say replace all of AS with what is equals to here, which is half V square. So bring down the M. So whichever way you want to put it, you will see that from force and displacement, you are able to get the same value. And you know that this is the same thing as saying W is equals to, bring the half one side, mv square. So this is how you get your kinetic energy. So you can use the formulas. So you can see that work is equals to kinetic energy. So which means that when it's moving, when something is moving, the work done there is as a result of the kinetic energy. When it's at rest, the work done there is called potential energy. It has the ability, the tendency to move. So the relationship between work and energy, that's what I've been able to draft and give you. So the potential energy, they say give the potential energy due to gravity. Potential energy due to gravity is equals to mgh, mass acceleration due to gravity, which is 9.8 times the height. Now they said give the potential energy due to elasticity. Potential energy due to elasticity is kx square. How? It is certain as saying potential energy is equals to, is directly proportional to the extension, or you say the length and the extension. And extension, that is length square. So its tendency when you stretch, especially a spring. So this k is a constant. Introduce the proportionality constant because it equals to kx square. So PE, potential energy due to elasticity, PE, this one is PE due to gravitation. Okay, this next question says, what is the force required to stop a 20-gram bullet whose velocity is 430 meters per second? From a pistol in a distance of 25 centimeters in a block of wood. So let's just write out what we are given. But what they're asking us is force. So let's write out what we are given. I have force. I don't know it. Mass 20 gram. And we don't make use of gram in physics. It's not chemistry. So then velocity 430 meters per second. Distance, S is what I will use, 25 cm, and we don't make use of cm. So let's convert this and get back. So we know that 1 kg is equals to 1000 grams. So let's do 20 divided by 1000. So m is equals to 0.02 kilogram. Then we know that if we have 10 millimeter, is the same thing. Yes. Okay, let's say we have 10 millimeter, is the same thing as saying 1 cm. And we know that the pattern we follow is kilometer, hectometer, decameter, meter, decimeter, centimeter. So remember, a millimeter. So if we are going this way, we'll divide. If we are coming this way, we multiply. So if we have 10, 1, 0, we divide by 10. So here is 1, 0, 0. So 100. Yeah, 100. So since we are going this way, we divide by 100. So 25 divided by 100. Or you can say, another way to know this thing is simply centimeter and meter, which one is higher? meter is higher. Anytime you are moving from less to higher, you divide, because what is inside the higher one is contained, what is inside the small one is contained inside the higher one. So this is going to give me 0.25 meter. So now they're asking us to get force. So we'll simply say, what is the force required to stop a train? So F, if we remember, there's no angle there, is equals to MA. F is equals to MA. And here we have mass. Then we have velocity. That means inside here, this is something that's mv over t. If you remember, but did they give us time? Okay, remember that work is equals to Fs, and this is the sentence as saying M A. Okay. If you remember very well, we said that work is equals to Fs and F is equals to Ma, and we've solved earlier on that work is equals to half mv square. And remember that work is equals to Fs, which means that we can have a case where Fs is equals to half mv square. So we can have a case like this, that Fs. So let's check. We are given mass to be 0.02. Then we are given velocity to be 430 meter per second. So 430 square. Then half is equals to displacement. We are given displacement to be 0.25. Then force, we don't know it. So this is the formula we can use. So any question like this, look at it again. So such a question, what we are going to use is this formula, which is Fs equals to half mv square. That is work equals to kinetic energy. So putting together everything, we'll have now let's punch. We have 430 times, so 430 times 430, you get 184,900. Then times 0.02 times 1 over 2 equals to F times 0.25. So we do 184,900 times 0.02. You get 3,698 times half. So 3,698 divided by 2, you get 1,849. So F times 0.25 is equals to 1,849. Then remember that we are looking for F. So divide both sides by 0.25. Then divide both sides by 0, the other side by 0.0. This will cancel this. So F, the force, is equals to 1849 divided by 0.25. So that you have 7,396. And force is Newton. So this is your answer. So to the nearest whole number, you can say it's F is equals to 7,400 Newton. So to the nearest whole number, it not say approximately. So this is your answer. Okay, let's look at the next question so that we'll call it a day. A police investigator measures straight skid marks 29 meter long in an accident investigation, assuming the friction force and car mass the same as the previous problem. What is the minimum speed of the car when the brakes locked? So assuming the friction force and car mass the same as the previous problem, what is the minimum speed of the car? Okay. Remember, we got this one using work equals to half mc squared. So let's try to look at this question now. So we have everything. That is problem 6. So we are assuming frictional force. That means we are taking it that opposing force, and you know that forward force and opposing force. So we're assuming that opposing force is 7,400. We're assuming that opposing force will be 7,400, and car mass will be 0. Mass 0.02 kg. Then friction will be equals to minus 7,400 to the nearest whole number. Then the distance S is equals to 29 meter here. What is the minimum speed of the car when the brakes locked? Minimum speed. Okay, you know that when the brakes lock, at that point, at the point where brakes locked, that is applied, definitely final velocity will be 0. Should be yes. Okay, let's look at it.